Then the depth we know is 30. The y bar is 30 divided by 2 plus y 20. Right? Because from the distance from here to here, right? If we section this is 20, this is 30 divided by 2. Okay. So this is equal to 30 divided by 2 plus 20 times 30 times 2 is equal to 2.1 times 10 to the power 3. So plus by 2.1 times 10 to the power 3 t. Let me do it again. 30 divided by 2 plus 20 times 30 times 2. Yep. So 55 times 10. So this is 27.5 times 10 to the power 3. Okay. So this is QZ at point B. Then we calculate QZ at point C is also equal to 27.5 times 10 to the power 3. Now we have up to B we have considered here, right? Next, we just need to consider the last part over here, right? So QZ at point C is 27.5 times 10 to the power 3 plus by 22.1 times 10 to the power 3 T plus by the width is equal to 50. The depth is equal to 20 multiplied by 20 divided by 2. So this is equal to 50 times by 20 times by 20 divided by 2 plus by 27.5 power 3 is equal 50 times 20 times 20 divided by 2 plus by 27.5 power 3 is equal to 37.5 times 10 to the power 3, then plus by 2.1 times 10 to the power 3t. So now we have everything, and the math is pretty straightforward from now on. So QZ at point B is 27.5 times 10 to the power 3 plus by 2.1 times 10 to the power 3t divided by thickness we don't know. And this is equal to 37.5 times 10 to the power 3 plus by 2.1 times 10 to the power 3t. And then we're going to divide by 50 because we're going to deal everything in millimeters now. Okay. So if we were to, oh, by the way, this is not T, this is 2T. You have to be careful down here. This is twice the thickness because you have thickness on the left, you have thickness on your right. Okay. So if you do cross multiplication, you will get 13.75 times 10 to the power 3 plus by 1050T. And this will be equal to 750T or not. I just divide and bring the T across plus by 42T squared. Okay, so 27.5 power 3 divided by 2, 13.7 by 2.1 power 3 divided by 2 is 1050. 37.5 power 3 divided by 50, 750, correct, 2.1 power 3 divided by 50. Yep, it's 42. Okay, so now when you rearrange this, you get 42T squared minus by 300T and minus by 13.75 times 10 to the power 3. And this is a second order polynomial or quadratic function. So thickness is 300 plus or minus b squared, which is 300 squared. Okay, so 300 minus by 4 multiplied by 4 multiplied by 13.75 times 10 to the power 3 and divide by twice of 42. Okay, so this will be equal to 300 plus or minus 300 squared minus 4 times 13.75 power 3, which is equal to 300 squared minus 4 times 13.75 power 3 but I have minus, I have a minus inside R. Okay, so it will be a plus by 4 times 4 times 20.7 by power 3, and then square root is 5. Wait, 42, Eugene, not 4. Sorry, rushing too fast. Okay. (42 times 13.75 power 3 times). Okay, so it's 1.549 times 10 to the power 3, and then the whole thing divided by 84. So this will be 300 plus by 1.549 power 3 divided by 300 plus 1.549 power 3 divided by 84 is 22.011 millimeters, or 14.869 minus 14.869 millimeters. Okay, so this is not possible because the thickness cannot have a negative sign. So the correct one is this one. Okay. So if you were to ask me, this is like one of the toughest form of questioning for this topic, to make sure that you understand the concept of Q over T ratio. Okay, once you clear this stage, yeah, everything is easy and straightforward. Okay, right. So the last part I'm going to do today is we are going to deal with composite shearing stress. In composite or sandwich material. Okay, like what you have seen in your term test. So there's also, for sandwich material, there's also consideration of reference material and also the thickness changes. So let's look at bending moment. If we consider bending moment, the equation for normal stress for sandwich material is we have this N, right? Then you have your mz over izz multiplied by y, right? For shearing stress, we are also very similar, okay? So our shearing stress, now you have Vy over Izz. Then you have your N, right? With, or N with multiplied by your Y bar, or with depth Y bar, and then you divide by your thickness. Okay, so it's very similar, but this over here is lumped under your what? Your first moment of area. Okay, it's lumped under your first moment of area. Okay, so it's not complicated at all. It's really straightforward, and I'm going to work this out as an example. Okay, you will see really clearly, and it's going to be much easier. I think for today this is the easiest example. So let's look at this problem over here. Okay, so what I'll do, since there's not a lot of space, I will do this. Okay, so we are going to do an example. Number 3 on shearing stress for sandwich material. So you can see in this problem over here, we have a steel bar, aluminum bar, they are bonded together to form a composite beam, knowing that the vertical shear coming down vertically. So we are given that Vy is coming down at 4 times 10 to the power 3 pound force. And the Young's modulus of steel is equal to 29 times 10 to the power 6 psi. And the Young's modulus for aluminum, we are sitting at 10.6 times 10 to the power 6 psi, right? Determine the average shear stress at the bonded surface, the maximum shear stress at the maximum shear stress in the beam. Okay, so likewise for this case, right? Depth is held constant, right? And the width changes due to what? Material type. Like bending moment, the concept is the same. Okay, so for this case, I'm going to select steel as the what? Reference material. Okay, we're going to steel for reference material. So N of steel is equal to 1. N of aluminum is equal to 10.6 times 10 to the power 6 divided by 29 times 10 to the power 6. So this is equal to 10.6 divided by 29 is equal to 365.517 times 10 to the power 3. Okay. So from here, we have to determine the centroid and IZZ. Okay, so I will just take the image from here. So we can, I don't need to flip around looking for the geometry. So we will have section. So section, I call this steel. And then the other one is aluminum. And we look at N. This is 1. This is 365.517. Times 10 to the power minus 3. Then we have our N width and depth. Okay, again the width is changing, so this is 1.5. The depth is 2, right? So this is equal to 3, and the other one is 365.517 times 10 to the power minus 3. The width is 1.5, and the depth now is 1. Okay, so this will become 365.517 power minus 3. So it's 548.276. 548